we are again. It's that time, my friends. Video notes are on the screen. Here we go again. It's that time, my friends. Video notes are on the screen. Ooh, yeah. It's all about matter. Ooh, yeah. This is all that matters. Here we are again. It's that time, my friend. Video notes are on the screen. Alright, thanks for tuning in to this week's installment of video notes from Mr. Flugum's chemistry class. Just so you know, these notes will go on page 17 in your chemistry notebook, And today we're talking about matter. When we talk about matter, the basic building block of matter is the atom. Alright? And what makes atoms unique is the atom is the smallest unit of matter that can still have the characteristics of an element. Okay, if you get any smaller than that, yes, it's still matter. Yes, it still has mass and volume, but it doesn't have any unique characteristics that elements have. Okay, you see here a pile of carbon, right? And that has unique characteristics because of the way the atoms are put together. All right, that makes its color, its shape, the states of matter that it takes on. All of those things are unique because of the structure of the atom. All right, here we have the periodic table of elements. And basically, every element that has been discovered is on this table. If it's not on this table, it's not an element. Now, an element is a unique piece of matter. The fact that this occurs, an element, all of the atoms are very similar. In fact, all atoms have to have the same number of protons in order to be the same element. So, the atoms are alike, all right, if you have the same element, all right? If they have a different number of protons, for example, it's a different element, and therefore it has different physical properties and characteristics. All right, now just a few things about the periodic table. The largest naturally occurring element is uranium right there, all right? That's number 92. There's most of the elements that are smaller than that are naturally occurring. There are a few that are man-made. For example, technetium, even though it's smaller than uranium, is a man-made element. Anything bigger than 92 is a man-made synthetic element, and most of those were discovered during the enrichment of uranium and other radioactive materials during the production of the first atomic bomb in World War II. All right, compounds. So compounds are a combination of elements, okay? But they're still kind of what would be referred to as a pure substance, just like elements, right? Now compounds happen when you have two or more elements combining together. All right, and they do that in a fixed ratio. So there's always a certain number of one element compared to another. So for example, this is a picture of a sugar molecule, right? Sugar is a compound, and it is C12. So there's 12 carbon atoms, H22. There's 22 hydrogen atoms, and O11. There's 11 oxygen atoms. If you change that in any way, it no longer becomes sugar. It becomes something else that has different physical and chemical properties. All right? Okay, so different from a compound or element, which would be known as pure substances, are mixtures. Okay? a mixture is this, okay? When you have two or more substances that are physically combined. So that means we can separate them without going through a chemical process. Okay? Now there's two kinds of mixtures, all right? One is called homogeneous or homogeneous. And if you remember back to your physical science days, a homogeneous mixture is one where when you look at it, you can't see the two or more different substances that go into it. So for example, this grape juice here, or purple colored water, right, is a homogeneous mixture. I can't tell the difference between the purple and the water. Okay? The other kind is what's called heterogeneous, like this rock here. Okay? In this case, I can see the difference between the different substances that make it up. So each different color within that rock is a different compound. Okay, so when I have a substance, whether it's a mixture or a element or compound, it has physical properties. So this is something that we can observe about it or help describe the element. All right, this is kind of like making observations about it. Okay, it can be its melting or boiling point, it can be its state of matter, it can be its appearance, its shape, its size. All of those are physical properties. All right. And then a physical change is this, right? You can see some examples there, all right? As long as a substance keeps its identity, it is a physical change, okay? So if the change happens and it's still what the substance started out with, for example, if I take some water and I boil it, that water has just changed its state of matter. It is still water. It's just in a gaseous state, right? So that makes it a physical change. All right, so now we have chemical properties. Chemical properties deal with the ability of a substance to undergo a change. For example, if something is flammable, or if something is corrosive, breaks things down, or if it rusts or tarnishes easily, as we have right here. Okay, think of the silver, the actual real silverware that your family may or may not have at home, right? It tarnishes because it reacts with the air and becomes something different. Now, chemical change is related to that because chemical change is a process that happens that makes something new. So combustion would be that, right? That's when we have flames and stuff. So, if we take something like natural gas, which is methane, CH4. What it does when it burns is it combines with oxygen and you get CO2, right? Something new, and water, something else that wasn't there before. Okay? So, chemical change deals with the making of something new. Same thing happens in your body when you digest stuff, right? It gets broken down and into something new. Something totally different that your body can use. All right, so how do we know if something has undergone a chemical change? Well, here's a few ideas, right? If color change occurs, for example, with this apple down here, right? That is a chemical change, right? Because we've got totally new color. Same thing right here with paper. As it turns black, it's changing into something new, right? You got flames, heat, or smoke, obviously, right? Because that means you have some kind of combustion going on, right? If you have a new smell, that happens. Okay, sometimes you just combine things together, and in appearance, it doesn't seem that much changes until the odor appears of a new gas or something being released. Okay, and finally, if you've got something new created, right? Okay, gas bubbles happen, a liquid that was there happens that wasn't there before. Okay, all those kinds of things indicate that you have a chemical change. So hey, when we cook an egg, is it chemical or physical? Well, You can see the answer there. This is a chemical change. Okay, the heat, as you expose the egg to it, changes the compound of the proteins in the white of the egg. Okay, and that makes it go from clear to white, right? So we have a color change that indicates chemical change. All right, hey, we made it to the end. Last slide. Bananas. You ever get those black nasty bananas that happen at home when you don't eat them soon enough? Well, what is that? Is that a physical or a chemical change? Think about it. We'll talk about it in class tomorrow, and I hope you guys have a great night. Thanks for tuning in.